I'm presenting on pseudo-bearing measurements for improved localization of radio sources with multirotor UAVs. There are a number of radio sources we might want to localize. A recent example is GPS jammers. These are illegal, but people sometimes buy them for privacy reasons. However, they can disrupt critical infrastructure and must be found. Another example is radio-tagged wildlife. Researchers sometimes place these tags on wildlife to track their movements and aid conservation efforts. Current methods for finding these tags are tedious and manual. There's been a lot of interest in using UAVs to find such radio targets. In a common method, the rotate for bearing method, a multirotor UAV rotates in place with a directional antenna. This yields a bearing estimate, and the UAV moves to a new location to repeat the procedure and get a new bearing estimate. By stitching together these bearing measurements, an estimate of the target location can be obtained. An issue with this method is that each rotation, and therefore each bearing estimate, takes a long time to perform. In the literature, it's often over 20 seconds. The reason a full rotation is needed to make a bearing estimate is to normalize for unknown scale factors like distance to the transmitter. These are patterns taken at different distances from the transmitter. They can be normalized if we take measurements simultaneously with an omnidirectional antenna. The resulting patterns are normalized. And so if we get a normalized measurement of about 3 dB, we can look at our normalized pattern and realize that the bearing to the target is probably about 40 degrees, or negative 40 degrees, or realistically a range due to sensor noise. These aren't quite bearing estimates, so we call them pseudo-bearing measurements. We need the omnidirectional pattern to be truly omnidirectional, so we hang the omnidirectional antenna from the UAV to minimize interference from the UAV body. We ran a number of simulations comparing the directional method with our directional plus omni method. Our method, the two antenna method with the pseudo-bearing measurements, often localizes the transmitter in less time than it takes for the directional method to complete a single rotation. Although the pseudo-bearing estimates are less informative than true bearing estimates, they can be made much more quickly, leading to faster overall localization. And in simulation, localization time is about an order of magnitude faster. We perform flight tests with a Wi-Fi router in an open field. Localization is slightly slower here because we are not running the same optimization that we did in the simulations. Instead, we're flying a fixed path, but the method is still validated.